Hey there, everybody. Welcome back. This is still 12.3 in Calculus 3, working on change of parameters, switching from time to distance with arc length. There's a couple other handy things that show up if we stop and think about them, which we can use to our advantage. And let's just go over them. So we've got some smooth function, RT. If we parameterize it using s equals 0 to t of dr du, then ds dt is just the magnitude of the derivative of the r vector with respect to time. So ds dt is the length. Since s is length, ds dt is the length of the tangent vector. Okay, at time t. Can we show that? From our example that we just did a little while ago in 12.2, or one of the examples before, we had the magnitude of dr dt was 9 sine to the 4th t cosine squared t plus 9 cosine to the 4th sine squared t. And remember doing this, we had 3 sine t cosine t. That's our ds dt. Dr dt that's our ds dt. Where does it come from? We had s equals 0 to t, the integral of dr du, magnitude of dr du. We take the time derivative of both sides. I've got ds dt on the left. On the right, this is the fundamental theorem of calculus. These two cancel out, and the t gets put in and becomes dr dt. That was our fundamental theorem of calculus. So we just took the time derivative of this formula up here, and ds dt falls out from it. So ds dt is the length of the tangent vector at t. And for every value of s, the tangent vector is a unit vector. So which means drds equals 1. The magnitude of drds equals 1. Note we're doing drds, not drdt. What we take the derivative of very much distinguishes it. We've got different variables here, different parameters. Where does the magnitude of drds come from? Check it out. We had ds dt equals the magnitude of dr dt from here. What happens if we let t equal s? ds equals the magnitude of dr ds. ds is 1. So the magnitude of dr ds, oh, look at that, fail. That Hefe didn't have a vector over his r. So the magnitude of dr ds equals 1. That's not necessarily the same thing as magnitude of dr dt. Okay. This was our crappy example from the last section. R of s had this weird value. It was 2/3 s to the 3/2, and then the quantity 1 minus 2/3 s to the 3/2. What happens with this? Let's just take a look at it. Try to get this on one screen. So there's our R of s. We take the derivative. I guess I don't need that page right there because I rewrote R of s. We take the derivative. Remember to bring the power down, drop the power by 1, and then take the derivative of the inside. The derivative of the inside's there. We do the same thing on the right half. We start looking at what cancels. 3/2 and 2/3 cancel. And to the 1/2 is just the square root. So we've got the square root of 2/3 s. Over here, the 3/2 cancels the 2/3. We still have a negative, so that's there. And we've got 1/2 is square root, so square root of 1 minus 2/3 s. We square both of these. The magnitude of dr ds That's yeah, DRDS. This is DRDS. Taking the magnitude of it, square each component. This is going to become 2/3 S. This is going to become -1 or 1 minus 2/3 S. So 2/3 plus 1 minus 2/3. That should have an S right there. From there, these cancel out, and we're just left with 1. So DRDS equals 1. And notice I didn't have a particular S I was plugging in. It just worked no matter for any of them. One last cool thing, if the magnitude of DRDT equals 1 for all t, the little thing we just did was DRDS equals 1. If DRDT equals 1 for all t, then S equaling t minus t naught is an arc length parameter with its reference point at t naught. We have S equals t naught, the integral of t naught to t of the magnitude of dr du times du. If dr dt equals 1 for all t, then dr du is going to equal 1. Because of that, we're just replacing it. T and u is substituted in. We've got S equals t naught to t du, because dr du is 1. We're evaluating u from t naught to t. So t minus t naught. And so that's the easy way of finding out what S is. If you know the magnitude of dr dt is 1 for all t. That's the purpose of this. If you know this is always 1, then you have an easy parameterization of S. 2S. So some equations we did in this section that you want to know. ds dt equals the magnitude of dr dt. And that's the square root of dx dt squared plus dy dt squared plus dz dt squared if we're doing 3D. And then if we look at not just, if we do drds rather than dr dt, the magnitude of those is 1. Notice, again, the parameter is switching to ds. It's not dt anymore. And that's it for this section. Peace.